Hey folks, so we are trying to do something new here. So all three of us are in the software domain, but we are now trying to understand, or we're trying to venture into core AI area. So at least and I'm sure even Hemant and Alan, they're not experts in the core AI libraries like PyTorch, TensorFlow, and the similar libraries like that. So what we have been discussing amongst ourselves since a long time is why don't we actually use AI to understand AI, right? So, and we have been putting that off since a long time. Now, finally, all three of us are together, and all three of us together will try to understand what ONNX Runtime is. ONNX Runtime is one of the open source libraries from Microsoft. And in this call, in this kind of session, we will try to understand it from scratch. None of us have looked into this before. We have no clue what it is. And in this session, we'll try to understand from the beginning, and let's see how far we go using AI. So that's what we are trying to do. I'm just trying to open the code.
You clone the repo as it is it?
I've cloned the repo as it is. That's what we have here. Should we start from the README? That seems like a good place to start. Or should we start straight away from AI? So before we ask AI, Hemant, Alan, any of you have any clue in terms of even the one-liner explanation of what ONNX Runtime actually is? I absolutely have no idea at all, apart from the name of the repo.
No, not me either. I know that it is some format to store the models or something. I remember PyTorch has some functions to, I think, persist the model, something of that sort. I don't think. Let us ask AI for that, is it?
Sure. I'm new to this repo. Please give me. Let's see what we get. Okay. We have got a bunch of stuff. So it is a cross-platform high-performance engine, the ONNX format. So I think, as you mentioned, Hemant, right? It looks like it is kind of serialization format. It's a way to store the model. At least one of the things that it does is it provides a standardized way to store the models. That seems to be one of the things that it does. Okay, so models trained in PyTorch, TensorFlow, etc., can be converted to ONNX and run efficiently. So,
so it looking like it is. It looks like it is doing both, right? It's not just like protocol buffers for model. It is something more by the looks of it, right?
Yeah. It just converts into a standard format, and also it provides runtime to actually run it, right? That's what it seems to be doing.
Right. In my mind, it was something like protocol buffers, but specialized for model. But it looks like it is not.
Right.
So people use speed.
Load model, build graph, optimize graph, partition across execution providers, and execute. So I think one of the USP that it is providing is that seems to be some optimization logic. If your model is stored in ONNX format, it might be able to optimize the runtime execution of it. So that seems to be the USP of the library. At least right now, I have no clue how it will achieve that.
I'm curious about this graph, though. What do you think would be the graph here? Like, I mean, imagine what in your mind, what is model? It is like a bunch of matrices. Is that like I'm thinking of say something dumb like, see, my limit is logistic regression, right? There's some incoming whatever matrix, and we have n by n matrix, and maybe some loss function or something, correct? So what do you guess is graph here?
So I thought the matrices that you're talking about are the kind of weights, right? So weights is the final thing.
Weights, yeah.
I was more thinking around it's a sequence of operations that your input will go through, one transformation after another, and at the end you'll get something that whole thing is your model in this case, rather than just the weights. I'm not sure if I'm right or wrong here. What do you feel?
Yeah, let me ask this guy once. But I mean, your explanation looks very promising to me.
Yeah, I don't have a good answer for this because it's saying that it loads the model, then it's building a graph out of the model, right?
Yeah.
That's what it's trying to say. So
I don't think it has explained graphs, so that is something that we can ask it to kind of explain further, right? So let us do that. What exactly do you mean by graph here? Incorporate the compiler plus runtime. Okay, this part was clear to us, I think. Compiler plus runtime for ML models. I think I'll just put it on autopilot. It's a computational graph, directed data flow graph. A neural network for any a series of math computations applied to data. ONNX represents that as a directed acyclic graph. So kind of something that I explained in the beginning, right? It's a series of transformations or computations that your input goes through.
Right.
And these are your operators: matrix multiplication, convolution, addition, ReLU, softmax, etc. And of course, the data is the tensors which are flowing through the different layers. So that explains the graph. Do you want to explore this further? I think, or we are clear at least with the concept of graph that this guy was denoting in the beginning.
Right.
So I was just trying to ask this outside of the code, right? And
same.
What it's telling me is that the ONNX runtime compiler works like, sorry, the ONNX runtime works like a compiler plus executor for neural nets. Okay. At a high level, it actually reads the ONNX graph. That means that is the starting point. And then it goes and actually tries to optimize it, partitions it, and then assigns the kernels for it. So finally executing whatever is required, right? So that inference part. So it feels like it's the model and the graph are not like totally independent, right?
Correct. So model is composed of the graph. That's what I understand. Maybe that is wrong. Yeah.
Sai, are we on the
So
right
yeah. I mean, I thought I asked similar question to AI outside. Like imagine I have a logistic regression model. Does ONNX runtime has any role to? It looks like and ask what is the graph in such a model. So it says that I mean it will be that sigmoid of WX plus V, right? A logistic regression. So what it is saying is the graph here is with nodes like matmul, matrix multiplication, addition because WX plus V and sigmoid. This is the graph. It is.
Yeah. That's what this guy is also saying. Similar thing, right? I think this was slightly more involved because it is not just logistical regression, but it's similar.
ReLU and softmax and all because of
but now what does this mean? So now we kind of understand what graph is. So a key concepts graph IR. Model is a graph of nodes, fine, and graph viewer gives read-only traversal, okay? Graph so you have some optimizers which work on this graph. Fusion. Right now, I have no clue what these are. Fusion, constant.
It will be able to do constant folding as well. Nice.
Okay, seems like you understand it. I don't. So I think we can.
I mean, I'm guessing it from the normal compilation mod. Like if you have say the sigma is constant, it will go and propagate that constant everywhere. I don't have it won't have to always look up that this particular variable is constant. It won't always have to look up that variable every time.
Okay.
That is typically how.
Okay. And then you have execution providers. I believe this would be based on the infra where the runtime is running. I think hardware dependent. Right. Each operator's actual implementation. Okay. The main entry point. Okay. So I think at least the part that we understand is what is it meant to do.
Right.
What do we want to explore further here? So what part do we go deep into to get more understanding?
Let us keep optimizer it a little bit aside, right? I'm still trying to. I think I have some vague sense of what graph is. Do we know what it means? The execution here. It will actually. Imagining in my dumb example, there is some sigmoid, and we learned it, right? So it is used at the inference time, or I can, by looks of it, I can also use it even for training, right?
I don't think you can use it for training. I believe this is purely for inference, right? Because you get a model from PyTorch or your scikit-learn, etc., and then you are just kind of. That's what I understood. We can ask.
Right.
It always. Let us actually not guess and ask it. Is this meant for only inference, or it can be used? Oh, I was wrong. Okay, inference is primary in the most. Okay, the repo has whole training stack under ORT training. Let me ground this in actual code. Okay, it does look like there are some specialized training support also, but it looks like most of the people are using it for inference because that's what this is also saying.
Right. Okay, that is interesting. Inference only needs the forward graph. Training has the machinery for the backward pass.
What makes the training possible?
No, actually, you are right. Inference is actually model is there and we are using. That is what you were saying, right?
Yeah.
So inference is the main use case, but training is possible. Correct?
Training is possible.
Am I reading this correctly?
Yeah. That's what it is trying to say. Yeah.
Okay. So.
Okay. So by default pre-built packages have inference only. Training requires a special build flag, not bundled by default. Okay.
So do you think the model is as a like if I trained on my laptop, whatever currently I'm on OS X. So will I be able to share it with you on that? Do you think it is the ONNX models are portable?
That's what it looks like, because it's standardized.
Looks like, right?
Serialization model for models. So it doesn't matter which machine I'm running. We should be able to share models with each other.
Okay, that is where that part of that hardware independence and all are coming there.
That is part of the execution, not part of how the model is stored. But while executing, it is same like your JVM intermediate code, right? In a way. That's what it looks like.
Right. Yeah, makes sense. So shall we try this? Let me ask again Copilot to generate a small. Again, I will stick to logistic regression. I will ask Copilot to generate one simple example for that using PyTorch or something, and export it and see. Right?
Yeah, that makes sense. So we'll actually try to run it using ONNX. That's what you were trying to say.
Yeah.
That will be a good exercise to start with. We can actually see the model also if we can actually read it to understand what it is doing.
Oh, there are some tools or something like that here.
It should be. I'm guessing. I'm not seeing, but
it should be, right? I mean, based on the documentation. Yeah, you're right.
Yeah.
Let me ask Copilot to. Create.
You want to share your screen? What are you doing?
Yeah, sure. Let me put it here. I'll ask it to create a PyTorch model. Make sense? Do you want to change? PyTorch works, right?
Yeah, it should work.
I am hoping it will ask me questions. I think this is too vague a question, right? Oh, it did.
Just used this thing, library and creator.
Is my screen visible to you?
Yeah. We can see it.
Okay. Yes, please create. Is it trying to do? Simple linear layer, okay.
So it just randomize the weights, right?
Yeah. Torch install, yes, I think I have Torch installed. Oh, remember. Let me just quickly run this. I believe I have, but oh shit, I didn't have.
You do the torch, I think, not PyTorch.
Wow, it's already there. Nice. Now we have some examples. What is this Python file it created? Logistic regression example. Yeah. I'm running it.
Yep.
What?
No module named ONNX script. Why is it asking for ONNX script?
Oh, ONNX script is not there. Okay.
But why do we need it for your logistic regression code using PyTorch? Oh, it's also
I'm
trying to. Oh, you're
to,
exporting. You're already exporting ONNX in the same script.
Yeah, it looks like it understood that I'm trying to do this.
Got it.
Yeah. Oh, wait. Let me see that code. What it actually created. No, it did not. So what is it? ONNX runtime. Oh, I think I understand. I think because I'm no. Oh yeah. ONNX. It has this.
And it's trying to run the inference also with ONNX after that.
Okay, shall I ask Copilot or we will only try and do?
We can try to running once and see what happens, and then we can see if we need to ask something.
Let us search ONNX. Oh God, okay. Sorry. I'll get my. What is the site it said?
PyPy.
PyPy.org search.
You can actually ask Copilot to install ONNX for you.
Yeah.
I mean, I'm too lazy that way, so I delegate this also.
Yeah. Let us do that actually. I'll inform this.
You can just tell it to run the script. It will do all of that.
Yeah, I think that should.
It sees the failure and will try to fix it by installing also.
Install it.
ONNX
install.
Yeah, please install for me. Sorry, it gave.
Hey, I don't want it to install everything. Yeah. I should.
I'm much more reckless than you.
Good, it is running.
Yeah.
Now you are not on Mac, right? Or you are also all?
I'm actually on Mac. All three of us are on Mac.
Yeah.
All three of us are on Mac. Okay. Next time I will try. What did it create? ONNX runtime. Oh, this ONNX file. ONNX.data. Yeah.
Okay. Will we try to inspect it first before running inference?
Yeah.
Like if you are,
shall we try and open it in a text file, right?
Yeah, let's see how it is structured. Yeah.
Yeah. Strict regression ONNX PyTorch 2.9.1. Is my screen visible?
Yeah, yes. But it is not very readable right now, at least.
Yeah, it is like that only. But, okay, and I'll see the data as well.
Oh, so I was trying to ask Copilot to see if there is a good way to view the file. So it is saying it's just a protobuf binary.
It's a protobuf binary. Oh, interesting.
That's what it says here. So you would need a tool to read it properly.
Okay. Now I got a .ONNX. What is the file I got? .ONNX file. It is searching for something.
Model viewing.
Netron. Go to ONNX. To ONNX. Okay. Oh, is that what it is saying to you as well?
Yeah. It gave me Netron and the ONNX package. So Netron is the best one in terms of visual representation. That's what I also got.
Netron, logistic regression. Local host.
Okay, let's start a server. You can just click on it. I think it is already.
It's already there.
Yeah, it should already be there.
Oh, I think I should be able to do it anywhere.
Yeah.
8,000, right?
HTTP.
80.
Oh, it is 80.
80.
My bad.
Okay.
Okay.
You guys are saying? Oh, it is too trivial, I guess. This is the graph, I guess.
Yeah. So inputs, I think this is matrix multiplication, right? And then sigmoid right. And then output.
Yeah. Let us ask Copilot on. I'll kill this guy. Oh, no.
Yeah.
Okay. Shall I describe it to this, or do you think it will be able to read that model?
It should be able to, I think. Let's try at least. Let's see what we get.
At the logistic. Okay, let me first ask it. That only prints the metadata, it seems. Yes.
So it wrote some code to understand it. Is that what you hit yes on?
Yeah,
Yeah.
Okay, interesting. It's just 2 rows, general matrix multiply followed by sigma activation. Excellent. Okay. Now,
Just as a digression, I was trying to ask it on the side to see if how LLM models are packaged. I was assuming that it cannot be just simple ONNX. Yeah, that's what I got. So yeah, one thing that is obvious is your LLMs have tokenizers, which this normal neural nets will not have. So that is also part of the packaging of LLMs. And because the weight tensors are huge, so they have some optimized way of storing the weight tensors. But apparently there is a sibling library of this, which lets people package LLMs as ONNX files also.
Wait, come again about the tokenizer part. I didn't get it. Why should, the tokenizer's model should be, I get it, should be tied to the LLM. But why would, what does it mean? Tokenizer is also packaged with this?
So that's what this guy is telling me that, okay, let me tell you verbatim what it is saying. So model package generally has 2 parts, the architecture, compute graph, the weights. And for the LLMs, weights are huge, like billions of params and all, like multiple GBs. And there is a third most critical piece that other simple models don't have, that is the tokenizer. So, so LLM packaging is really about having all of these 3, plus having an efficient storage for this giant weight tensor. So that is the explanation it gave me, that why is it not simple to just use a simple ONNX file to store LLMs. But then it went and told me that, okay, there is a library which actually lets people do that. But yeah, it is not this ONNX Runtime one that we are checking it out. It's a sibling library of it.
So, okay. But still, it is not making sense in my...
It's okay. Probably we can come back to it. I think we are exploring the simple logistical regression model for now. Maybe we can come back to this later.
Now, let us ask how it can be used in inference, right? What can be, we'll ask it to write a small program to where it just loads this and provides some inference, right? Then we can see how the code looks. One comma 4, it is like, oh, super dumb this, right? Model this is. I'm killing this guy, right? This network. We don't need
we don't need that visualizer.
What inference example? What? Okay. CAPI. Okay, I'll ask it to run it.
Sai, like for everything he's saying, please do it for me.
Yeah, hey, there is some study, you know. The more politely we do, higher the chance of accuracy.
Oh.
Yeah.
Yesterday I was doing some dumb.
Moreover, I don't want to get into that habit of commanding it. I will start speaking the same thing.
Yesterday I was doing some dumb work with it. It helped me so much. I was so happy. At the end of every single milestone, I was patting its back. Thank you so much. Such an amazing job.
I think we are still not used to this level of. If
this
someone
level of
is
efficiency.
From a pure computer program, right?
Yeah.
I think that Rust is coming a bit naturally. Oh, okay, it works. What did it install?
ONNX Runtime.
ONNX Runtime.
That's all it installed. Okay.
Yeah.
Yeah, that's what it looks like.
Okay, from a different directory to avoid conflict. It ran it from another library. Oh, interesting. Another directory, sorry. Okay, so now let me see the code. Run inference. NumPy ORT.
What are we trying to do now?
I'm just trying to see what inference means. What is the code it generated?
Oh, okay. It must have given some sample inputs and just.
Yeah, it gave some sample
it would have loaded
input and.
Yeah.
But I thought, where is it trying to? What is it? So it just runs
session.run.
I think that completed this, right? I mean, this rest of it is only trying to show that it matched. I guess.
Session.run is what session is the model, I think, where it loaded the ONNX file as a model.
Yeah, session. A session is this one. Yeah, makes sense. So what we did here, we created a model, stored it in some ONNX file, and then that was part of. I mean, after we trained, assuming we trained. After training, we asked PyTorch to rely on ONNX to dump the model in a format, and this in the inference session we just loaded the ONNX and ran it.
Yeah.
Right?
Yeah.
Then there is this optimization and all are coming because
so that I think we need to dig a bit deep into what exactly it optimizes here. I think that is because I think this is a very simple model. Probably there is not much to optimize. So maybe there are some scenarios where that optimization would kick in.
No, but I was wondering, PyTorch would have already done that optimization, right? No. So why would it? I mean, where is the scenario where during inference it needs to?
Maybe let us ask Copilot. Maybe there are some operations that it can optimize, but not sure how. So probably we can ask Copilot.
You want to ask or in the session or
you're already sharing? So you're already sharing the screen, so probably you can just go ahead.
Let me do it. What sort of optimizations does ONNX Runtime do? You can do during inference. Multiple ops into one.
I think, but this must be your architecture dependent, right? Whether it is running on CPU or GPU. So that would govern whether it's able to do these kind of optimizations, right?
Oh, I understand what you're trying to say. I understand. Okay, some of the optimizations are specific to this, so that is the reason PyTorch may not. I mean, it may not be advisable to actually store the optimized format in the model, right?
Possible.
Is that essentially what you're? Okay,
possible.
Yeah.
So sorry, I didn't understand that. Like, isn't the selection basically based on the hardware? Which part are we talking about? The last one, right? Hardware specific kernels that are there. That is when it is actually used to execute, right?
I was actually talking about the first part.
Operator fusion.
I will try and put Priyank's statement in my words. Tell me, Priyank, if I misunderstood it.
Yeah.
Say for example, this mat mul plus add to jump, right? This is the optimization it tried to do. It is like combining multiple ops into one, right? Now, is this always an optimization in every hardware? Not necessarily, right? Maybe in case of CUDA, maybe because of the way we perform the way parallelism works on CUDA and all, this may or may not be an optimization. So there is no point when we are creating the model that it may not be. If we put it optimized, it may not always be an optimization. Did I get that correctly?
Yeah, that is correct. But again, thinking again, why won't PyTorch do it is what I'm trying to ask, because even PyTorch can understand
PyTorch would do it only with on my machine, right? My OSX machine, right? It may not. I mean, whatever my optimization may not work for.
Here we are talking about the runtime optimization, right?
Runtime optimization. Yes.
Yeah.
Runtime
so then it makes sense, no? That basically you have these set of operations depending on the hardware. What is the right set of things that it can collapse down?
Yeah.
That would change. So that the runtime decides. So then it makes sense.
But again,
so I'll just still ask, right?
Okay. Yeah, let's do that.
Something like constant folding, right?
Please tell me, Sai, why?
Apparently, it's a great question. And it is done at export time, but there are good reasons ONNX Runtime does it again at load time. Framework gaps.
Okay.
Oh, it is more than Acha. Okay. Yeah, makes sense. Okay, excellent. Understood. Do you know what EP specific folding means? What is EP here?
No, I'm just trying to read, but yeah, right now I'm not able to understand that part.
Yeah. Sorry, you take your time to read this. Is the screen visible?
No, I read it, but it's still not clear to me. So if you understood, maybe you can help.
Right. I'll ask the. I mean, the other 4 points seem to make sense to me. Right. Just to be on the same page.
First part seems pretty clear. The framework gaps. This is what I was trying to ask. Why wouldn't the framework itself do it? It looks like, okay, not all frameworks are that.
Right.
Maybe not every framework has that optimized implementation. Fine. So that is a theoretical possibility. Second, I understand at a very high level that, okay, there are some things that all the optimization cannot be done at the export level, but when you're actually running inference, some things are known. So you can actually be more aggressive.
Yeah, the batch size and all may determine that, right? Because that is at the this. Right.
But should we actually, sorry for asking a very dumb question. So for people who have not studied compilers in college like me, can we go into what exactly folding is so that it's more clear? At least that in itself is not very clear to me.
I'm coming a little bit from the C++, this kind of thing, like const expect kind of. Okay, let me not talk out of my. I mean, imagine we have. I have some place where in this is some programming language somewhere. I said int x is equal to 3, right? And then later on, I know it is the same x, and I'm saying whatever x into x squared plus 3x plus 1, right? Is some y is equal to x squared plus 3x plus 1, right? Now, because x is known, we can substitute x here. Now y is known. Now and y is used somewhere else. Y will also be this, right?
Got it. Okay.
Right now, what they are saying, if I believe so. We can confirm it in a minute, and or we'll in our next video maybe I'll correct myself if something more than this. What here they are saying is it is not necessarily whatever I said about this x is equal to 3 and this and all. These are all like compile time constants. Here, the compile time and runtime are kind of this, right? In the sense, at the time of inference, the model creation is separate. So in the model creation, they said so there is some number. Say 312 into batch size is something is used there, right? But batch size is at the runtime, right? So they can substitute something of that sort.
Now it makes sense.
Yeah. Then post-export modifications. This is something I mean, I can imagine that people would want to do some post-export modifications. We live and die in this extensibility, right? So kind of sort of understand that part. And portability again is also making sense. I think that is your point, right? I think that matters a lot.
Yeah.
So only what EP specific. What is EP though?
So I checked out here. It's saying it's execution providers.
Oh.
So what?
Okay.
What exactly is an execution provider in this context? Yeah, you can ask it.
Could be CPU versus GPU, like CPU versus CUDA, no?
It is ONNX Runtime's abstraction for a hardware backend.
Yeah, CPU, CUDA,
yeah,
TensorRT.
Yes, is correct.
Okay. Yeah.
Okay.
Oh, we can choose that. Okay, so shall we go? I mean, I think that was a good question, right? We can actually double click on how constant folding does by how ONNX does constant folding, right?
Yeah.
No, do you want to do that?
Let's go ahead.
I think I should have asked it to create an MD file or something, right? So that we can.
Oh, you didn't hear the latest announcement from Anthropic? MD files are dead. Now it is HTML.
HTML.
Yeah.
Oh, because of the tags and all, is it?
I mean, no, it's more. It's more visual, right? It can be interactive if you want. That's why. They wrote a blog about it.
My guess it's more tokens. They will.
That is also there. Yes. More tokens.
I think Alan has the appropriate level of cynicism.
Yes. I was trying to be politically correct, but yeah, I think that is the right answer.
But outside of that, I think the other part is also that they want more of their scenario all more for the non-technical, non-engineering.
Yeah.
Right. So as they get into all of those business scenarios, they need something that is not scary like a MD file for those folks.
Yeah.
Okay. Let's
All
see
inputs
this
must be constant initializers. Must contain subgraphs. Just 1 minute, please.
And we'll have to ask her to explain each and every line for me. This is a lot.
Kind of same for me right now.
Do you understand what are shape nodes?
No. Where is it? I didn't even. Okay, that one. Special cases. Yeah, if you go to special cases, it will be tough only because.
Yeah.
I think we will have to ask you to dumb it down, at least for me.
Yeah. Same here.
I'll be back in 2.
Sure, sir. So I tried asking on the side, okay. I know Sai is not here, but it gave a nice example that I think Sai and you were also trying to explain that. Say you're got an, first of all, it's a whole graph, right? Now it needs to find out that within this graph, what can I go and pre-compute? So let's take an example that it reached one node where it was, it's a multiplication, matrix multiplication, but all of the inputs are known, they are constants. So it can go and do the computation right there, get a value, replace the matrix multiplication operation with just a constant. Yeah, with just a constant. Now it keeps doing it for the entire graph, and then it actually goes back to see if at all there's further optimizations.
Yeah,
that means
because of the first one, it'll have to redo the pass, right? Because there might be additional.
Someone that has a dependency on that, now it becomes a dependency on a constant, which again can be folded down further. So it keeps doing that until there's, well, I don't know whether it's until or what the terminating condition is, but once it reaches a point where it can't optimize, then that's it. It has folded as much as possible.
Sorry, I'm back. So we got clarity on this, is it?
Kind of.
Yeah.
I think you know about this better than us.
No, I'm just but I think shall we see that class or what next?
Yeah, we can do that.
Yeah.
Core optimizer constant building.cc. Where is it? Core. CPP, yeah. I'm not getting, where is that? Full include.
You want to see the constant folding file, no?
Right. It is telling me it is in, right.
It's there in core optimizer, ONNX Runtime core optimizer.
I'm not seeing core at all. Yeah, it is saying I'm not.
Not seeing core.
Right. I thought there will be some SRC or something like that. Oh, ONNX Runtime. Yeah. Or optimization. Optimizer constant. Huh?
In that, there are
Constant folding
transformers.
.cc. This guy, no?
Yeah,
This is only, no?
other.
Yeah.
I'll just see the header file once, please. Okay. Oh, graph transformer. Okay. Okay, these are constructors only. Allow constant folder. What are the functions from the parent class? These are private. Okay.
It looks like only the graph transformer and then there's a ONNX runtime graph transformer.
Sorry, what?
So you were looking at the parent class. No, sorry, continue. Sorry, I'm looking at
No. I just going over the comments there. To handle the shape need separately. Okay. So it needs to run at the inference time, right? When it is loading the graph or something. I mean, I'll quickly go over this run inference file. So this guy should run at this point, correct?
Correct.
But our example is too trivial. I thought maybe we can introduce some change here, build it, and see it running or something. But it looks like our example will not have much there, right?
But what would you change? Like what did you want?
I mean, I will add some, I don't know, print statement or something like that to see it running. Yeah.
Yeah, we don't even know right now whether it. I mean, this optimization even conditionally is executed or always executed.
Yeah.
It would depend on the graph also, right? I don't know. So.
Correct. That is what I mean. Yeah, I think our graph is too dumb, right?
Yeah.
This guy is too trivial. Shall we ask it to make it introduce some?
Maybe we can give this model, your ONNX file to Copilot and ask whether constant folding will actually run on this.
Okay. Not really. Your model has this. Constant shines in larger model where you have chains of orbs running on pure constant. Okay. So there is nothing to pre-compute here. Okay.
Yeah. Because input will always be dynamic.
Right. Okay. Shall we ask it to get some models from somewhere?
Yeah.
No, right?
Yeah.
We need some model that will load on a machine.
We can always get some image recognition model. I mean, they should be fine to load. Simple image recognition models.
But it would be better to go and first take a look at how exactly it looks in that Netron, right?
Yeah, we'll
see
do that.
How if we can guess that what would be kind of merged.
Yeah. Just for fun, I'm trying to build a random animation on the side to explain how it does folding.
There's in folding also, it has got like 7-8 categories. Constant folding is just one of them. No, constant folding is just one type of folding that it does.
Oh, okay.
Net.
Shall I run it on Netron?
Yeah, that would be good. Let's see what it shows.
66 nodes. So this looks like a big enough model.
Okay, what is the file it downloaded? SqueezeNet, okay. Whoa. It is going on and on.
Alan, you want to take a manual path at this?
Okay, now let's ask it the same question that you asked earlier. So what do you say, Priyank? What is the answer? What will it say?
It will run. I mean, it should be able to find some nodes at least.
I say it will say maybe.
Yeah, I think maybe seems like more possible answer.
Constant for a limited relevance. Okay, so it looks like it's a more than a no.
Some other optimization is relevant. Constant folding is not. Okay, shall we try and do that? Okay, let us ask for it.
Right? I think operator fusion seems like a more common optimization. It looks like probably.
Shall we do that? Let us finish off this constant folding. No, where
we can... sure. Yeah, okay.
So what do we want to do with the constant folding? You're trying to get some other model.
Which benefits from actually, if someone talks like that, that will be super fucking annoying. Let me create one. Yeah,
it gave up on us.
Oh, it actually was thinking about GPT-2 model.
Sorry, what did you say?
In its thinking traces, it mentioned GPT-2 might be relevant. PyTorch exporter is too smart. It already folded constants during export.
I asked it to download, and it second guessed me and tried to do whatever.
And what does it mean when whatever Claude is doing stuff and saying I'll do it manually? What's the meaning of manually for it now?
Okay.
So 1 minute it's saying multiplication, add, and then you multiply.
Input. So this is input. First, so this entire thread is constant should be constant for.
Even The first matrix multiplication can be removed, no? This one.
Here, but if the these two are multiplied, this I think this will be this only this and
matmul and add.
this.
But those are not constants, right? Like on the left hand side, that A4, those are not constant, right? That's the size of the matrix, right? B
well,
is
it
the
must
constant.
have already some matrix because these are the weights. Imagine it trained, right?
Okay.
Those are by definition.
So if it is constant, then A into B can be a constant, and that will be collapsed into matmul. And out here also, then the left hand side both can be collapsed, right?
Yes.
It can be collapsed till this point. Here, it cannot collapse beyond this point. It has to multiply with.
Okay. Yeah.
Right.
Okay.
But something so obvious would have been done by exporter only, ideally, no? How did it manage to not do it?
No, it did it specifically for us, no? Because we're asking.
Yeah, I think so.
It did.
Let us see that script very quickly. What folding demo. Create constant folder.
Graph before fine.
Input matmul, add output. Yeah, great. So
it has generated the graph. Helper make model from graph.
oh, it has that constant mode. Oh, let us run this guy. Then I think it will.
But 1 minute before you, what's the library on top? There's no library, right? As in, it's not used any ONNX or anything, right?
It is using.
It is, but for what is it using ONNX? Just to put it out as output format.
I think it is using that optimized, where I saw some optimized. It's called ONNX.load. It is reloading the same thing. At that point, we should get that.
Okay.
I think this is giving exactly what I think, right? No.
It's giving so what? Sorry.
It is giving what exactly we are looking for. Like.
Yeah, I was just trying to see that if at all some library was used, then it wouldn't have any control on generating that graph. So it created the graph manually. And that's why it is left as it is. Right? Isn't that what's happening?
Build model. I don't know what build model is doing here. Let us quickly see. It created a graph and model is called helper.make model, check model and make model.
So that make model part is just taking the graph as input, right? What is manually generated.
Right, I guess so. What is helper here?
ONNX, import from ONNX.
Oh, there is something coming from ONNX. So we have model. We just if we are not using PyTorch or anything, is that was what you are trying to say, right?
Yeah.
Understood. Makes sense. We just created a drum model and then okay, let us run it. We will see the two after constant folding what happened and all, right?
Okay.
So before keeping optimization demo, ONNX Runtime not installed. What the hell? I have it.
Keeping optimization.
Because I was on that other guy.
You're running it inside some kind of a container or that Python runtime or?
It's runtime not running. Okay, I will also go and do in some. It should not install anything. It ran. Okay, first initially it is matmul of W1, W2, mul of raw bias, scale bias.
Isn't it not matching what we were assuming?
Sorry?
Is it what we were assuming? Because out here, what is it saying? Input combined weight. So this is just a multiplication, right?
Yes.
But we were saying that there would be 3 different operations.
No, GEMM is that, right? That it will include that both multiplication and this. Let me confirm that part.
Okay.
Shall I go back to that diagram once?
Yeah.
Sorry.
वो उधर खुला था ना in your browser.
Yeah. So what we are expecting is this matrix multiplication plus this add is what we expect, right? Because this is till this point we have constant. So this plus this is what we expect, right?
Right.
I think that gem itself is that.
So it's multiplication plus addition, is it?
Plus addition.
General matrix multiplication.
ABC output A into B plus B.
Oh, there is a bias factor. No, so yeah, addition is also there.
So yeah,
instead of separate mul plus add nodes, yeah, Gam does both in the one fused operation.
So it is fitting with our thing, right?
Yeah.
Yeah, sounds good. We can maybe some other time we can actually go and make the change in the code and see, but at this point it is too vague to actually go and.
Yeah.
We don't have if node. We don't have shape node. Oh, we don't know whether this is. Can we print add some statements here and ask it? No, that means we'll have to
rebuild
some R library, right?
Yeah.
Yeah.
Next time, what we should do, because this is a whole bunch of C++, right? I don't want us to waste time on building this. Next time, maybe we should have this library built.
Even building ONNX Runtime using the source. That's what you're trying to say, right?
Sorry?
You mean building the runtime using the source code? That's what you're trying to say.
Yeah. I thought it would be like if we add a few print statements or whatever STDC outs, and then actually run that constant run there, and we can see it printed.
Okay.
So that we know which of these functions are getting called.
Yeah, we can do that.
With what values.
Yeah.
Okay, but I'll quickly ask, what is the class name I forgot?
Actually, these guys have got a bunch of agents to do exactly that. Build the entire thing.
Oh, is it?
Oh, the report itself?
Yeah. There's an agents.md file.
Oh, I didn't realize that.
I had opened it. See the ORT build skills in this.
Yeah.
Shall I ask it to build it, is it?
Yeah, that will build it. Just type /
Okay,
ORT
then
build.
that means we'll have to give up on experimenting with my code, because I'm guessing the C++ build will take a while. My guess
Yeah,
will
leave it aside or start it in a different shell if you want. I've started it anyways. Just it's
yeah,
fine.
you started it already. Yeah, no,
yeah, we'll do it for next time anyways.
Yeah.
Update build skip dash.
Looks like there's a C# runtime also.
Yeah, C#, Rust, and Java.
Oh, Rust is also there.
Yeah.
So Java is also okay. Now I see it.
Apparently, we can use it from Android as well.
Oh, okay. I do remember we actually tried to use it for one of our actual features, but something did not work out.
It did not. Yeah, I remember that. At least, was it when Gopal was here?
Yeah, it was for the scoring feature for seeding. I think we wanted to use it within the plugins.
Right. I mean, I remember that was like on batch we will run that and get the ONNX runtime, and we will do the inference from core services, something of that sort.
Not even core services. I think we tried the inference from the plugin itself using the NuGet.
Oh. Okay.
That was the plan, and this is a while ago now.
Right. Yeah, but yeah, I remember the C# part. I thought it will be on core services, but yeah, makes sense.
This was before core services. I mean, this was before we had core services.
Oh, you're talking about that. I remember because there were these talks of supporting out of box, right? I mean, making it available, say some basic modeling exposed for everyone.
Yes. This was in the same context.
Yeah. Okay, we seem to have reached some logical state. What next? Some hint on constant folding we got.
Yeah.
Do you want to see that are there any issues around? Do you think it will have a GitHub skill?
GitHub skill.
Will it be able to search for me?
Yeah, that I did.
Yeah, this.
Yeah, it'll do it automatically. You can just ask it.
Oh shit. GitHub issues I should have specified, right?
Yeah, it's looking at GitHub issues.
Calm down.
It is looking at GitHub issues.
Yeah, it said if they are open GitHub issues or known problems.
Oh, okay. But it actually just gave its own theoretical issues. It didn't search the issues. We can actually ask it to do it.
And also think of general issues that I have.
Look at what?
Give a link to the GitHub issues. Yeah.
It won't require it.
It should.
It has the current repo context. In fact, that's why it is saying hash issues at the bottom. It knows how to search.
Mentioning constant folding. Oh, shape. I think Alan, you were saying something when I was stepping out about shape thing, right?
Yeah, basically we were talking about the explanation for constant folding and that there are other types of folding. There are 7-8 different types of folding.
Right.
So we were just discussing that. Shape folding is one of them.
Why is it doing web search, man? Priyank, I thought it should have some tool.
I don't know. It suddenly started doing web search, but anyway, we got what we wanted, I think.
Numerical discrepancy.
Safety optional.
Different accumulation order in the folded kernel, thread safety.
Race condition. Wow. QDQ patterns. Unexpected behavior. These are still open now.
I think these are open issues. All of them are open issues.
Okay, let us understand. Shall we go? Shall we go there? 2480. To reproduce. So we don't, unless I sign in, I won't get it, right?
Don't get what?
See the description. I thought there will be some other comments or something.
On this, it's you cannot contribute, but it doesn't look like this.
There's a PR.
Any comments on?
There's a Copilot PR for it already.
Okay.
It's draft.
What is it trying to do? Wow. It asked itself, or is this a question?
No. The human asked Copilot, is this sufficient above? It is quoting
okay.
that.
Yeah. Sorry. Yeah.
Quoting that.
Let me quickly see this, right?
This we need to understand the current implementation first.
Yeah.
But morons like me try to fix this without even understanding it.
You're telling Copilot is a moron?
No. I'm attempting to understand this.
You will understand it. It's some eigenmaps and Khan's summation algorithm he's used for what? Before that, what is the issue? Did you understand the issue?
Yeah. I mean, imagine there is a big. I will try. I mean, imagine there is a input is a vector, and we are doing a sum. Apparently, the resulting sum has error. Is in which floating points we are expected to find errors, right? We are expected to see discrepancy between. Floating point comparison is not a deterministic thing, right? Two floating point. Because the difference between them is like we are supposed to compare against some error value or something like that when you are doing in numerical calculation. Here, I think the bug is saying that we are the error they are seeing is too high, especially when the input is a big matrix or something like that. I don't know what exactly it is. Bitwise identical, right? That is expected. So what they are seeing is after constant folding, the error rate is beyond the expected value. So I believe what it tried. So if you see, I think this will help us understand, right? So what it tried to do here, I'm guessing it should create one huge double. See, one matrix with this. And we should expect this guy. What is this expected? So these 5, multiplication. Okay, sorry. So what we are expecting is the delta should be within this range. So,
Okay.
right now, this guy, we should go there. It added this comment. Now, what we want, what it tried to do, what is the fix? Earlier, it was narrow.
I don't even understand this narrow operator, right? Why was it problematic and how
let us
this
ask
fixes
that.
it?
You know what is ORT?
ONNX
What is
Runtime, right? The
runtime?
name that is
Okay,
used.
okay.
Oh. Then why is that? And ensures that data is not lost. Oh, interesting. So it replaced that with a loop. Okay. I don't know. I mean, I'm too stupid to understand that this will be a fix. But looks like there is no comment about this code, right?
Homework for us before next
Yeah,
time.
let us do that.
Yeah. That's a
Shall I
good
put
idea.
this?
Priyank is the expert in like how part 2 coming soon.
Sorry?
Like
sequel. I'm setting up the sequel.
Sequel, yeah, he's
Yeah,
setting up for the sequel.